Hey everyone, so in this video I'm going to explain the decoding process, assuming we start with the binary chunk 011 1000 1000. In the previous video I explained how we arrived at this binary sequence. In this video I will show how do we actually decode this binary sequence. So in this example, remember this was the original probability distribution for the symbols. We start with the interval from 0 to 1. We divide it according to that distribution. So that binary sequence, you can easily calculate the lower and the upper boundaries using the binary expansion. You'll find that it's 0.441406, 441894. So you look at the distribution of the probabilities, and you'll find that this is where the binary sequence fits in the interval from 0 to 0.55. So that means the first symbol must have been a 0, since this tiny sliver, which represents this binary chunk, is within that 0 to 0.55 part of the probability space. So that says the first symbol must have been a 0. So what you do is similar to what I explained in the article. You take that part of the probability space and you shift and rescale, and you divide it into so almost you project these probabilities into that space from 0 to 0.55. So that gives you the potential, the eventualities A0, 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 A1, A0, A2, A0, A3, A0, A1, and you can easily calculate the lower and upper boundaries of these tiny spaces. So if you do that, you'll figure out that from 0.385 all the way to 0.4675 is this part, and this is where this binary sequence fits completely. So that tells us that A0, A2 is where this is actually living, which tells us the A2 is the next binary sequence, is the next symbol. So we take that A0, A2 and repeat the process. So we do the same thing. We do the shifting and rescaling. We take the space from 0.385, 0.4675. We map all these probability distribution onto that space, and then we see where that sliver, this binary chunk, intersects or fits within that probability space. And then you'll figure out that the next probability, the next symbol is A1. And that process continues. And in some cases, there is no way to tell where to stop, actually, because the binary sequence is so small that you can continue this process indefinitely, almost indefinitely. So how do we eliminate this ambiguity? Well, there's two ways we can eliminate this ambiguity. The first way is we can specify the length of the sequence. We can say, well, we have 4 symbols to decipher. Or the second possibility is we can say the end of the sequence is, let's say, symbol A4. So one process of decoding, once I hit that symbol, once I found that symbol, that means that's the end of the message, and I stop there. Otherwise, there is this ambiguity, and there is no way to tell where to stop. In that particular example that I mentioned in the article, actually the process was definitive, and there is no that ambiguity. But in other examples, the process could be ambiguous.